What do you see is happening in Pakistan when you look at our buildings and you look at our cities?
These kinds of buildings are designed for northern climates, different kinds of elements which are not incorporated in Pakistan typically. These houses tend to get very hot and you need to use a lot of energy to cool them down and then heat them up in the winter. It's called EPS or expanded polystyrene. Even this one is going to offer you about 90% reduction on how much of the heat is coming through the walls. The other component is air tightness in the buildings. Throughout the year, the sun takes a little bit different path in the sky. This can be used. So by strategically placing the windows, trees, gardens, they're not only beautiful and relaxing, but they also cool down the surrounding environment. When you have dark asphalt surfaces, you have concrete buildings, they absorb sunlight and then they will radiate the heat late into the evening and into the night. I'm trying to help engineering students to understand these concepts and how they could be improved in a simple, cost-effective ways that suit Pakistan and not just blindly copy solutions that work in some other country.
Welcome to MT Out Loud, जहां बस बात कर दो। I am Aliya Agha, and today's topic is something that concerns all of us. We have seen Pakistan's urban area sprawling and actually becoming very, very large. And the architecture in these cities is completely changing. Before, we had indigenous architecture of our homes, havelis, where we would see courtyards, where we would see verandas. And these elements in our homes would actually bring cooling and heating to the homes by itself. We have seen unprecedented heat waves in Pakistan. And due to climate change, it seems that we have to modify what we are doing. We have adopted architecture that is from the West, and those countries have different temperatures. Today, we have invited an expert, Mikko Ekström. He's a construction expert from Finland, and he is looking at architectures in Pakistan, teaching at New Tech University. And today we are going to talk about climate resilient buildings. Welcome, Mikko.
Thank you.
Mikko, it's very interesting that you have chosen Pakistan as one of your destinations to come and study and teach design and construction. How come you chose Pakistan?
It is true. It is a little bit unusual story. It starts in 2018. I had a long-term friend who I studied with in Finland. He moved to China and he's an economics professor in there. Through him, I met a Pakistani student who studied in China. And it seems that when you meet one Pakistani, they will also introduce you to their friends. So this is how I kind of got befriended with a number of Pakistanis and who were studying in China, and actually even some of them even living here in Islamabad. So they invited me to come here. I came here first time in 2021. It was a very nice experience. I spent 2 months in Gilgit-Baltistan in a place called Kaguj, not far away from Gilgit, and then also in Skardu. It's pretty cold in Finland, so I decided that now that I have the chance, I could come here and spend the cold winter months in Pakistan, and then now summer is returning to Finland, so I'm going back home for summer and then hopefully returning again in October.
That's great. So what do you see is happening in Pakistan when you look at our buildings and you look at our cities?
The problem is that you had great architecture and design, ingenious one, but now you have incorporated elements from the West. So you use reinforced concrete, you use burnt bricks, but you kind of left it halfway. So these kinds of buildings are designed for, like you said, for northern climates, and they're also designed for, you know, this mechanical ventilation and different kinds of elements which are not incorporated in Pakistan typically. These houses tend to get very hot, and you need to use a lot of energy to cool them down and then heat them up in the winter. And this is uncomfortable for the residents and also very wasteful in terms of money and energy. And this is something that I'm talking about in here at NUTEC. I'm trying to help engineering students to understand these concepts and how they could be improved in a simple, cost-effective ways that suit Pakistan and not just blindly copy solutions that work in some other country.
Yes, because now we see that there is a vertical growth in our cities, which was never seen before. This is not how our culture and our living and our lifestyles really were. We lived in ground floor plus one. And this is how maximum 2 floors. But we never had homes that were very high. So this has changed the way we are living. But as you said, it is about energy, and they become very hot, especially that we are using certain material, not just concrete, but we also use a lot of glass now because it is aesthetically very pleasing, and we want to make our cities look like New York, or perhaps even other cities like Hong Kong, where you have vertical buildings and all in glass. How would you suggest? Because I think now there is more trend of involving architects and engineers when we are designing buildings. But before, or even most of the homes would not even have architects and engineers. They would just have draftsmen. And it is up to the owner where he wants the glass and where he wants the doors. So what do you suggest in terms of if somebody is building their house, how should they be insulating the house so that, the electricity can be saved? In fact, it's interesting. It's not about saving the electricity. We don't have electricity. We see a long hours of load shedding. So we really need to understand from experts like you how to make a home cooler in summers and warm in winters.
There's no short answer to that. The good news is that Pakistan has an ideal climate for energy efficiency. Although you have extreme climate conditions, say in the extreme heat in the summer and extreme humidity in the summer, and then you have fairly cold weathers also in the winter, but on average, the temperature is quite ideal. Even in the wintertime, you have days are fairly warm. And even in the summertime, the nights are fairly cool, relatively speaking. So you can kind of store and you can ride over, you can smoothen out these extremes, if not throughout the seasons, but at least throughout the day. And this is one of the components. If you have a proper energy design and engineering for the house, you can achieve very big savings in terms of, not just energy consumption, but electricity consumption. It's not that difficult to actually, and it's not that expensive either to have something that's called a passive house. So basically you use very close to zero energy in heating and cooling of the house just by choosing correct building materials and using some clever design tricks in the design of the house.
This is an interesting term, the passive house. So as you said, some tricks we need to learn. Initially, our homes were made from bricks, and then bricks are still used in, I think, more of the northern side. But we have adopted concrete blocks, and concrete is one of the worst materials when it comes to, climate and environmental problems. So how do we actually start to cool a wall, for example? I see that you've brought a few things with you. So I would like to know, and especially even for my house, I would like to learn, how do I cool or heat or insulate my walls?
It's very specific when concrete is good and when concrete is bad. Concrete can be wonderful also in terms of climate and energy efficiency in combination with the right materials. So concrete has a lot of desirable properties. For instance, you can shape it into different shapes, and if you build the house, reinforced concrete house in a proper way, in theory it can last for indefinitely. In Rome has built concrete buildings without the steel reinforcement, but those buildings are still standing today after 2,000 years. So there's no reason why concrete houses would have to, be torn down. And if you compare it to, say, wooden buildings here, if you build a house from wood in here, that house would not last anywhere near as long as concrete would or stone would. to go more specifically, how to then use this, I talk about insulation system, and insulation system has three components. So the classical one, which most people are familiar with, is the prevention of conduction of heat through the walls and the ceilings. This pink sheet, I'm sure some of your viewers have seen this. This is called extruded polystyrene, XPS. I bought this from Bindi.
So it's locally available.
It's locally available, and I think it's also locally made. This one is an excellent insulator. It is not susceptible to water. It doesn't absorb water. It does not let through humidity. It can be a good thing or a bad thing depending on the context. But most importantly of all, it has very low thermal conductivity. And thermal conductivity means how easily heat travels through it if there's a temperature difference on two different sides of the sheet. So this is the first component. And for instance, my house in Finland is built with something similar. Chemically, the material is same, but it looks a little bit different, and it's called EPS, or expanded polystyrene. But the principle is the same. You can put this on the external side of the concrete wall or brick wall. It can be attached with glue and mechanical fastenings. And then on top of this, you can either, if you have very light sheets, you could glue here with that cement. You could glue pieces of stone, or you could use plaster, and then have this look like your traditional houses, in walls in here in Islamabad. This is about 1 inch thickness, or 2.5 centimeters. And even this one is going to offer you about 90% reduction on how much of the heat is coming through the walls. But remember, we are talking about the system. This is just one of the components. The other component is air tightness in the buildings. So you traditionally, you had these houses, like you mentioned, that you have gardens and courtyards, and wind and air gets to move freely through the house and cool down the house. Now, this doesn't really work nowadays because the cities here are very hot. The outside air is very hot. It's also very polluted, so you don't necessarily want to have the outside air blowing through your house and bringing all the dust and pollution. So you want to have an airtight house, because if the air moves, say we have an AC in this room, and if this cooled, conditioned air escapes to little cracks in the walls, or between the door or window frames, and if the windows on door don't properly close, that energy is completely lost to outdoors. And then, of course, some air must come and replace it, and this air is then hotter, and you have to again air condition this, and this is very energy intensive, especially in the summertime if you have very humid air. I recently did a brief calculation, very simple one. In Karachi, if you run the AC for 5 hours, the hottest hours of the day, you have a normal, typical air conditioner. So it's not a very inefficient one, but maybe you didn't clean the outside unit. That would cost about 12,000 rupees per month just for one room, just because of the air leaks. And this doesn't factor in, the conduction through the walls, or any other heat load from the appliances, like lights and computers and whatever heat generating things you might have.
This is significant. I mean, 12,000 rupees per month for one room, and usually a home would have at least 3 to 4 rooms occupied. So no wonder we have very high electricity bills that are coming up. So these things that you're talking about, they would actually seal the air coming in from the windows and the doors?
Yes. So the idea is that you control the airflows. Of course, we must have fresh air. We cannot just bottle up the house and completely prevent all air exchange. The idea is that we prevent the uncontrolled air exchanges. Nowadays in Finland, we use completely mechanized ventilation, even in small houses. This means that you have a pipe that sucks fresh air from outside, and it goes through this machine. There's air filters that will clear out the dust and some of the air pollution. It goes through heat exchanger, where it meets the cool conditioned air from inside, and then some of that energy is transferred between the airflows through a different kind of a heat exchanger. So you don't actually blow out the cool air that you have paid for. You can recover up to 80% of that energy in that air through this way, you not only get considerable savings in electricity bills, but you also improve your own personal health. So you can have very easily up to 80 to 90% reduction in in dust, say particle size of PM10 or even PM 2.5, depending on what kind of filtration system you use. And if you have some industrial pollutants that can go through these kind of mechanical filters, you could have active carbon filters to take out, like these nitrous oxides and sulfur compounds or whatever industrial pollutants might be in the air. So it's not only about just saving money, it's about promoting the health of your house and, making it easier to clean and maintain, because now you have far less dust in there.
So in your opinion, with such high amounts of electricity bills that Pakistanis are now paying, and they're also cribbing a lot about it, what do you think is the energy consumption in the residential area?
I know that's from national level. I can tell you that.
At the national level.
National level, 50% of the electricity produced and consumed goes to residential sector. And about half of this, from about 40 to 60%, goes into cooling, just cooling the houses. This includes fans and air conditioners. This is far more than in any industrialized country.
So we talked about the walls, and you had some very good suggestion. And we also talked about the windows, how air can infiltrate. What about the ceilings, the rooftops? Because we are using all sorts of things to cover the roof, but these are kind of little square cement slabs which have like 4 little legs, and they say that if you cover the roof with that, the air would go underneath it and keep the roof cool. But we haven't seen drastic changes with those as well.
I haven't seen those, but based on what you told me, I wouldn't expect a big change in this, especially if they're made out of concrete. That there is a little separation gap is a good thing, but the problem is actually with the material, what's above it. This concrete will absorb heat from the sun. This is, by the way, the third component of the insulation system. If we had the insulation sheets and then the air tightness as the first two ones, this is the final component. These tiles that you described, they would absorb heat from the sun. They would get hot, and all objects, including humans, we radiate close to the temperature that we have, at the temperature of 33 to 35 centigrades. That's the surface temperature of our skin. Same thing goes for these concrete blocks. So they heat up with the sun. If they're dark, they can reach its temperatures up to 60 centigrades or even 70 centigrades, depending on the conditions there, and then they will radiate at the corresponding intensity below them, and then the roof will then absorb this radiated energy and pass it down to the next floor or the floor below. And this is why you don't really see a big effect. These tiles, they merely slow down the process. They don't really stop it. So for that one, I actually have another 2 samples here. I'm sure that
we've seen this in the market, and people cover their walls so that the neighbors can't peep through.
Exactly, but this can be also used to shield your house from the sun. What I did in my house, I put this to cover the rooftop. Still that you can walk underneath it, you can still use the space, but this prevents direct sunlight from reaching the rooftop. I have also here this thermometer here. Without touching, it can measure the temperature of surfaces. So if I just press a button, it tells what's my hand temperature is 34 degrees centigrade. So I used to measure the rooftop temperature before installing this and after that. So before installing it, it would go up to 55 centigrades. And this is not even dark concrete. It had light stones in it. But if you have darker concrete, it's not unusual to see temperatures up to 65.
So light and dark surfaces would actually react to heat?
Yes, it's one component, because when you have sunlight, you have 2 major components. So you have the visible light. So the lighter surfaces which we observe as a light surface, those reflect visible light well. And all radiation, be it visible light or this thermal radiation, infrared radiation, when it gets absorbed, it will be converted into heat. So this is why it helps. But unfortunately, when you have these stone and concrete structures, they typically are very good absorbents of infrared radiation, which is another big component of solar radiation. So about half, more than half actually, comes in the invisible infrared radiation. And this is where these sheets can come handy. The idea is that, as you can see, this is a little bit shiny. It reflects some of it away.
Right.
And then it absorbs some of it in here. And it will radiate it also back, also a little bit down. But the temperature of this sheet will stay considerably lower than concrete. And when you have space underneath, air, even a little bit of an air movement can cool down the surface below. And even if there's no air movement, when the concrete below gets a little bit hotter or warmer, then natural convection will mean that the hotter air will rise up, cooler air will come down, and then it will cool down the surface again. So if I say that before using this sheet, I could see up to 50 degrees. And after this, I would see very close to the ambient temperature, so somewhere in the range of 30 to 34. So if it was 30 degrees outside, then maybe 31 or 32 degrees. And then in the same time, without spots with this was not covered, I could see then 50 centigrades. And this will over time also, throughout the day, it will come through and will radiate from the top of your roof.
We also, in Pakistan, love glass. And in our homes, we've started to adopt large windows, very, how do you say, Arizona style homes, or even buildings, as we discussed, like New York style skyscrapers with a lot of glass that reflects the light and absorbs light, perhaps. What do you suggest for that?
There's actually, depending on your budget, there's a lot of new exciting products. There's something called low E glass. It can selectively block or reflect different spectrums of electromagnetic radiation what the sun emits. So these can be engineered to reflect a lot of infrared radiation. So this would block out about half of the solar radiation. So even if you have a directly exposed glass to the sun, the best products can, cut out almost half of the heat load from that compared to the traditional glass products. You could have multiple layers of these glasses to then also keep the conduction through the glass in the winter time. I'm sure you have seen that when you run AC, if it's a little bit humid outdoors and you have a single pane window, then you get condensation on the outside.
Yes.
Now these modern glasses with multiple layers, they will completely eliminate the problem, because the gap between the glass panes also insulates the outer pane. So the outer pane is very close to the outdoor temperature, and there is no chance for the
I think we call them double glazed glasses.
Yes, and actually in Finland we haven't used those for decades. When I was born, triple panes were the standard, and nowadays we use quadruple panes. So we have 4 separate glass panes in the window.
I have to give this instance that we did have these double glazed glass, but the heat was too much still. So we tried to put a reflective sheet on the outer side of the glass, and it cracked.
Yes, it is possible, especially if you have that there is the whole window is not exposed to the sunlight equally. This is very much possible that you can have this kind of thermal stresses, and then these stresses will then basically crack the window. I can't comment on more closely because I haven't seen the setup. If you don't want to go these fancy high-tech solutions, there are budget options as well, which are actually even more effective. And nothing stops you, even if you have high budget, nothing stops from using these. I'm sure everyone has observed that throughout the year, the sun takes a little bit different path in the sky. Now in the summertime, the sun is very high up.
Right.
And in the wintertime, it's very low on the horizon. This can be used. So by strategically placing the windows, if you avoid placing them on the south side, or if you must put them on the south side, you can have a competent architect or an engineer to calculate the sun's trajectory. You can ask them to do energy simulation, and you can have something on top of like a ledge on top of the window that will in the summertime it will provide shade from the direct sunlight, so the direct sunlight cannot get in to heat up the room. But in the wintertime, when you want to heat up and when the sun is lower, now the ledge is no longer stopping the sun's rays to going into the house, and now you actually get a boost from the sun to heat up your house.
You interact with students at a university. What is your assessment, or I would say, how do you see young Pakistanis? Do they want to change these practices which are harming the environment, are living, and are more energy consuming?
Yes, at least my audience has been very enthusiastic about these things when I've been talking about them. Some of the students have come to me and asked me to tell more or with specific questions. And one student just today, I talked to him and he said that he would be willing to learn about this energy modeling if I'm willing to help. And I'm more than interested because I don't know anybody here who could use these modern building information or modeling softwares. BIM, it's called.
So now from homes and buildings, let's go a little bit further. Let's look at the cities. You will see that the cities are becoming concrete jungles. Our roads, our pavements, even homes. I mean, the homes are getting smaller, so people are using every patch as filled with concrete. There are hardly any garden patches or grass patches, and we see that parks are disappearing. How does this contribute to heat and water levels, especially coming from rain?
This is a good point, and this is what's been often ignored all around the world, and what is now cities and city planners are waking up to. So nature serves an important function also in urban areas. So trees, gardens, these kinds of little patches of nature, they're not only beautiful and relaxing, but they also cool down the surrounding environment. When you have dark asphalt surfaces, you have concrete buildings, they absorb sunlight and then they will radiate the heat throughout the, late into the evening and into the night. And although the sun is down, you still feel that, okay, it's really stuffy and really hot walking on the street. And it's all because the stored up heat onto these built areas. So if you can have these roads, you can have these things, but if you have three elements, ponds, maybe a bioswale, so this kind of a artificial creek, so it might be dry when it's not raining, but when it rains, the rain will collect into this depression on the ground that's not covered, and you have these kinds of plants, trees, and flora and fauna in there that lives there. It slows down the speed at which the water will then rush down to nalas. And if you have a flash flood, I think you have had a couple of pretty bad ones in the last 20 years. And it's exactly because of this. When you have concrete and asphalt surfaces, the water cannot absorb into the ground. It will just flush down to the storm drains, and from the storm drains they go directly into the nalas. And when you have a lot of water coming at the same time, then you have flooding in the downstream. So this kind of a natural way of handling the water will slow down the rate at which water will go down, and will reduce the risk of flooding in this kind of flash flood type of situations.
I'm so happy that you have shared your experiences and your knowledge, and you're in Pakistan imparting those as well to new architects and engineers. I wish you all the best. Thank you so much for being on MT Out Loud, sharing your knowledge, your expertise, and continuing to teach that to Pakistan.
Thank you. It was a pleasure to be here and talk about these things.
Viewers, I'm sure you have taken great points from here. I think we need to adopt certain strategies, and these were not very expensive strategies. However, this will impact immensely our energy bills. It will impact immensely our lifestyles, our health. At the end of the day, we need to understand that Pakistan is deficit in energy, and we need to all come together and not spend on air conditioning or even go for lifestyle in buildings that are going to create more heat and difficulties for us and for our children. We hope to bring more experts and more knowledge for you. Keep watching.